All right, this is for my geometry crowd. We're having a little bit of trouble with our IXL and specifically properties with radicals and operations with radicals. It wasn't something, as I look back through our book, we did go over it, probably not as deeply as I would have liked, but that just helps me for algebra this year to know how deep I need to go in preparation for geometry. So thank you for that, and thank you for listening. We're going to start this video with adding and subtracting radicals. Whoop, where'd that come from? There we go. I'm having a hard time writing, as you can see. So I'll just slide down here since I keep running into something with my stylus. So add and subtract radicals. And let's start off. This actually came from Kanan. She kind of directed me towards some areas that she was having trouble with. And I'm so grateful, Kanan. You are awesome. And if you didn't ask the question, somebody else may have had the same question and may have been too embarrassed to ask. And I'm so glad that you felt comfortable writing me and letting me know, hey, I need a little bit of help. I'm always here for you guys. In fact, I am apparently, when Kanan's ready to go to high school and then Chapel Hill and then a medical school after that, I apparently am going to be going with her, and then we're going on the mission field to Africa. I think we're doing pediatric missions, and I would love to be a part of that. I will be your assistant, Kanan, anytime you want, even though you might have to push me in a wheelchair. Okay, ha. That was just a little bit of a joke there. Hopefully I'm not going to be in a wheelchair. Okay, so let me get some radicals up here and let's talk about adding. We'll start there. That's a good place to start. The key is to look at radicals and treat them as though they're variables. Remember, if the variables are not the same, we can't add them together. Now, there's nothing I can do with x plus y, but yes, I can add x plus 2x, which will give me 3x. Same thing is true for radicals. If you don't have the same radical in each of these terms, you can't add them together. So you're going to treat the radical, I'm going to kind of replace them with variables instead. And you would look at that and you go, oh, I know what to do there. 8x plus 3x is 11x. Well, the same thing is going to be true with the radical. These don't change. The square roots don't change. They're like. So we're trying to figure out, well, how many square roots of 7 do I have? I have 8 in this pile. I'm going to add 3 more to the pile. I have a total of 11 square roots of 7. Hopefully that makes sense and that resonates with you. Let me put one up here that doesn't have like terms. Let's look at 8 times the square root of 2 plus 3 times the square root of 3. 8 times the square root of 2 plus 3 times the square root of 3. Notice, hey, we do not have the same radical. Guess what, guys? I can't add these together. I can't physically put them together and make them one term. It's impossible. So let me kind of put it to algebra, back to algebra a little bit. If you take 8 times the square root of 2, and let's make the square root of 2, let's make that our x. And since the square root of 3 is different, let's make that our y. Remember when we were doing algebra, we couldn't add those together. They're not like terms. I'd have to leave that answer as it is. Same thing here. Leave it as it is. It's already simplified. Okay? So hopefully that's a little brush up on adding radicals. Let me get a clean sheet here. And let's talk about subtracting radicals. This came off of IXL. This was an actual IXL problem. Okay, guess what? Adding and subtracting, the rules are the same. You can add or subtract if, as long as the radicals are the same. Okay, as long as they're the same. So it's as though I was treating the square root of 3 as though it were the same exact variable. So let's change it to 8x minus 9x. You go, oh, I know what that is. That's negative 1x. Or just negative x. Same thing. Okay, so let's get back to our radicals. Hey, they're the same, which means I can combine the coefficients. 8 minus 9 is -1. And so you can write it like this, or you can just write it with a negative sign out in front of the square root of 3. Now remember, you cannot subtract if they don't have the same radical. So let me change this one and make it like this. Guess what? You're stuck. This has to be your answer because you have two different radicals. And because they're not like, you can't put them together. So you're stuck with 8 times the square root of 2 minus 5 times the square root of 3. That's your simplified answer. Okay? Now you can get a little bit more in depth. You could do addition and subtraction where the radicals aren't already simplified. Like for example, you have 2 times the square root of 20 plus 4 times the square root of 5. Now, the average person might look at that and go, hey, not like radicals, I'm done. Okay, that's the untrained eye. You guys are the trained eye. Notice that this one's already simplified. You cannot simplify the square root of 5 anymore. So that is simplified. 4 times the square root of 5 is like a reduced fraction. 2 times the square root of 20, that 20 can be reduced. Okay? So if I take it off to the side, and we'll kind of, I don't know if this will bring you back to the class time when we talked about this in algebra. Think about it for a second. Is there a perfect square factor? Now, what do I mean by perfect square factor? Think of numbers that you can take the square root of and get a whole number as an answer. You're not getting a decimal, you're not getting an irrational number, you're actually getting a whole number answer. And that list would be, like I can take the square root of 1. Square root of 1 is exactly 1. The square root of 4 is exactly 2. The square root of 9 is exactly 3. So it's these numbers right here, 1, 4, 9, 16, 25, 36, and so on. Those are perfect square factors. So as you look at the number 20, and we kind of do a factor tree just a little bit, think about it for a second. What can you think of a perfect square factor? 20's got a couple factors. Okay, let's list them. We don't really want to use 1 and 20. That doesn't get us anywhere. But there's 2 and 10. Are either of those perfect? No. 4 and 5. Either of those perfect? Aha. Yes. So we could rewrite the square root of 20 as the square root of 4, which is perfect, and will get us exactly the number 2, and then the square root of 5. So I can reduce the square root of 20 to 2 times the square root of 5. Okay, so that's my little dot right there. Hopefully you see that between the 2's. Okay. Now what we need to do here is exactly what it says. We need to multiply those two numbers outside of the radical. We need to multiply them together. So that becomes 4 times the square root of 5 plus 4 times the square root of 5. Oh, wait a second. Remember up here it was very deceptive. It looked like we couldn't simplify it. But wait, once we simplified it, what do you notice? Hey, we have the same radical, which means I can add the coefficients together. And now I'm done. So you do have to look for that. That's a possibility. I don't know if you'll encounter any of those types of problems, but you definitely need to consider it. At least scan it and look for it and see if you can reduce it. Okay? So that's it for this video. That's adding and subtracting radicals. Just a brief kind of brush up on that, trying to make it less than 10 minutes if I can. So great job. Of course, if you have any questions at all, don't hesitate to email me or text me or call me. If I don't have your phone number in my phone, I probably won't answer the call if I don't know who it is. That's just me and my human nature. I'm sorry. I'm just a very private person. I don't randomly answer phone numbers I don't see and I don't know. Okay, the next video I'll do multiplication. Okay, thanks for listening.